Welcome to my class. Yet again, we continue discussing object-oriented programming with Java. At this point in time, we are still discussing, classes and objects, and we continue this path. This time around, our focus is on topic 3, defining classes and creating objects or instances of a class. Okay, so let's just make progress. So the previous video lesson, I did show you what we call a class diagram, which you draw using Unified Modeling Language, UML. So in this case, we just continue from that point on, and we look at now how we can create actually an object, how you can instantiate an object, how you can actually create a real object. Remember, in our discussion, we say that a class is a blueprint, it's a template, it's an idea, it's a concept, it's a plan. So a plan is not real. You can't live in it. You can't stay in a plan, a house plan. But when you use that plan to build an actual house, so the actual house is said to be an object. So an object is real. A class is a plan. An object is the actual object, a real thing, whereas a class is a plan. So in this lesson, we are going to look at how we can define, how we can create that class, the house plan, and how from that house plan we can create actual objects. That's the purpose of this lesson. When you create a class, we say you define a class. And then when you use that class, which is a plan, a template, a blueprint, to create an actual object, that is said to be creating an object or instantiating an object. So let's take a look. So we use a class called circle because we want to simulate a real circle in a real world. You know that when you look at shapes, there's one of the shapes called circle. So we want to do a class called a circle. And please also remember what I taught in the earlier lesson, an introduction to classes and objects. I mentioned that when we talk about a class depicting a real-world object, say the real-world object can be something physical that you can touch, or it can be something nominal that you can only, allude to. For instance, a bank account. A bank account is not something you can physically touch, but you can model it in OOP using a class. So in this particular case, we are modeling a shape called a circle. A circle is not something you can touch, but it's something that you can model, because the circle has attributes, the state, and it also has behaviors, the actions or operations. Okay, so we use a circle class as an example to understand how we can define a class. What do we mean define a class? Creating a class, a plan. And also how we can create an object. What do we mean creating an object? Instantiating an object. So from a plan, how do you create an actual object? This is what we call creating objects. Okay, we move on. So here's an example of a program. Remember in the previous lesson, I showed you a class definition, a plan in OOP, Java programming. Now here we have a program that makes use of that class I showed you. Let me just maybe move backwards and show you that class so that we can move together. We'll come back to slide 32. Let's just go to that class I show you. This is the class. Okay, so let me start from there. So we have the circle class. This is the definition of the class called circle. So this circle has all the particulars that you want for a circle. So the name of the object is circle. It has methods in it, and it has a data member called radius. As you can see here, data field member called radius. So now, this is just a plan. It's not an actual circle. It's a plan telling us that using the features I'm showing you here, you can create an actual circle. So that is what the class I'm going to show you, the one I'm just from, does. That class makes use of this class called circle. Let's go to that class. Okay. There we go. So this class called test cycle. We use it to test that plan, that class called cycle. So we'll use this class to test that class to make sure that it works. Those features it says it has, can we use them? So using this class, we're going to test that class. So when you look at this class, it says public class test cycle. So the name of the class is test cycle. Now this class contains the main method. Okay, I would advise as usual that if you don't understand functions, you don't understand methods, you need to start with chapter 1 in the prescribed book and make sure that you follow the study process from chapter 1 up to where we are. This is chapter 9. So if you're lost, it means you have to go backwards and make sure that you study chapter 1 up to 8. Now, if you did go through first year and second year, there's no need for us to start from chapter 1. But if at all for some reason your foundation in introduction to programming is weak, it is built on sand, it's a house built on sand, and when a storm of rain beats upon your house will come down crashing. If that is the case, if that is your case, you don't understand the programming fundamentals taught in first year, you have to go back to chapters 1 to 8 and make sure that you do those chapters before you come to this video tutorial. If you know nothing about chapter 1 to 9 because you skipped first year or you chose, and I'm using that phrase carefully, because you chose to ignore the importance of the first year subject introduction to programming. You don't understand whatever you learned in introduction to programming. You have to, please, I'm emphasizing, you have to go back. Please go back. I'll say it again. Go back to first year material. Make sure you understand what a function is. You understand what an array is. You understand what a control structure if statement is, what a switch statement is, what the control structures for loop, while loop, do while loop are. If you have no idea what I'm talking about, please go back to first year. I'll say it again, go back to first year material. Whether it's C++ or Java, it's up to you. You can do Java, you can do C++. The point is, if the foundation is missing, it's lacking, please go back to first year. Go back, go back, go back, go back to first year. If your foundation is weak, go back. But whatever I'm talking about here, you are lost. When I say method, I say function, you don't know what I'm saying. When I say constructor, you'll be lost because you skipped first year. So for those of you that are on paper in third year, but in practicality, you're still in first year. In fact, you're in first year, first month of first year. Please go back to first year. And then when you're done with first year material, chapter 1 to 9 to 8, then you can come and continue with this video lesson. I've emphasized because it's critical, it's important, it's necessary. That knowledge is needed here. It's needed, it's needed, it's needed. So go and get that knowledge. So some will not teach you first year material. So if you lack that foundation, please go back and start building your house, programming house on a solid rock. Please go back to first year. Otherwise, if your grounding in introduction to programming with C++ is solid and just okay, you understand whatever you learned in introduction to programming, from introduction to programming languages up to introduction to classes. In first year, you did recursion, you did pointers, you did arrays, you did control structures, you did functions, you did elemental programming. Then you're safe to start from here, chapter 9. If that is not the case, please go and start with chapter 1 of this prescribed book. Study it up to chapter 8. Then you can come and continue. I've emphasized, I know you ignore it, but ignoring what I'm telling you, ignoring to go back to first year will make you fail this subject. So don't ignore my advice, go back. Each time you come to watch this video, remember what I'm saying. Go back. Go back. If you don't have first year foundation, go back. So each time you try to open this video, just remember my words. Go back. Go back. Go back. First year. Okay, we make progress. So now I'm talking to people that have a grounding, solid grounding in first year introduction programming. So those are the people I'm expecting to be watching this video at this stage. If you're watching this video, but your first year is weak, please go back. Okay, so we have this class called test cycle, and then we have the main method. And the main method, as you learned in first year, is the first place where execution begins for every program. So when you run your program, the first lines of code to be executed is the first line within or inside the function main, or rather, as we say in Java, the method main. So in this case, because this is a Java program, so it contains, and this class contains the method main, which is starting at line 3. So therefore, when you run this program, the first line to execute will be line 4, which is a comment. Because it's a comment, it will be ignored. So the next line to be executed will be line 5. And line 5 is an instantiation of an object called cycle1, whose data type is the name of the class called cycle. So here we create a variable whose data type is a cycle class, because the data type of this object cycle1, line 5, cycle1, because the variable cycle1 has a data type which is the name of a class, name of a class. You can see where my cursor is. Name. This is the name of a class. So because this variable's data type is the name of a class, therefore we say this variable ceases to be a normal variable. It now becomes an object. Why? Because the data type is a class name. And in Java, which is a normal, sound, and appropriate OOP programming language, when you create a new object, it is always better and necessary to create an object using the new operator. Otherwise, you experience errors. So please get used to this idea. When you create an object in Java, you must use the new operator. So then you need, when you create an object like cycle1, you need to say assigned to, then you use the keyword new. This is called the new operator. So it creates, it allocates a reference to an object in memory. And then you say, after new, you say the name of the class and then the brackets. I'll explain this later, especially when you do inheritance. For now, just know that each time you create an object, just say assigned to new, and then you bring this name of the class to the right side of new and you put brackets and a semicolon. That's all. Okay. And then line 6, this is something familiar. We've been dealing with this, and you know how to print out the contents. So we're saying the area of the circle of radius. We continue. Plus simply means join. The plus simply means join what is on the left, join it what is on the right. So we'll join in this sentence the area of a circle, the area of a circle of radius. After the word radius, can you see that there's a space here? There is a space before the closing quotation mark. There's a space. Therefore, this plus joins this space, this sentence together with the space, joins it to whatever this will return. Now, what does this return? This returns, we are saying here, cycle1, the object we have created here, we say dot radius, meaning we access the value contained in radius. Now, remember, in that class, I'm showing you, radius contains the value 1. So therefore, 1 will be returned when this happens, when this object activates the radius data field. So the data field contained there is 1. So 1 will be joined to this. So 1 will be, after this space, 1 will be joined. So it will read as the area of the circle of radius, space 1, and then there's a space here after one. After one, this will print one. This will print one. So when it prints one, there's a space here. So it will print a space and then join the word is, and then print a space and join. Each time you use plus with a string or an object, it will join instead of adding. So it will join this space and then it will join it to, again, we call now, we use the object we created here in line 5, circle 1, and we activate, we invoke the member method get area. So this will return the area of a circle, which is radius times pi. So the area will be returned, and that area will be joined to this space after is. Okay. The rest is the same. So line 10 to 12, same concept here as line 5 to 6 to 7. The same line 14 to 17, same concept. Okay, we'll discuss some of these. So here we sent nothing, meaning the object will be set to radius 1. Then here we are sending 25, meaning the radius will be set to 25. Here we are sending 125, meaning the radius will be set to 125, and so forth. Here we are setting the radius directly to 100, okay, and so forth. So the results will be like this. Okay, continuing, these are the functions you can see here. What is it? Okay, you can see these are now the individual functions. So when you don't send any value for radius will be set to 1. You can see line 32. When you send something, when you send some value, for instance, there we send 25, so new radius will receive 25, and then 25 will be assigned to the variable radius. This one, the same, this one gets the area, it calculates the area. I told you that to calculate the area, it's radius times pi. The answer will be returned. I think I have explained this, and that's how it works. So we continue, and this is the result. So it will report that the area of the circle of radius 1 is that. Of radius 25, it's that. 125 is that. Radius 100 is that. I hope it's clear. Okay, moving on. So the program constructs 3 circle objects with radius 1, radius 25, and radius 125, and displays the radius and the area of each of these 3 circle objects. I've already explained this. Then there's also the last part that was after setting the value of radius to 100. I also explained, I showed you that. Okay, so it will display the new radius and area. Okay, that was an example on the test circle class that we use to test the circle class. Let's move on. So its sole purpose is to test the second class, which is the circle. Okay, so such a program that contains the main function and is used to test an actual class, a plan. The program that is used to test a class is called a client program. So that's a client program. So test class is a client program. Test circle is a client program. Okay, we move on. When you run the program, the Java runtime system invokes the main method and then begins to execute the details within the main function. I've already explained it, so you can pause the video and read through these notes. I think I can skip these. Okay, the public class is just a class that doesn't have the main method. So every class that contains the main method, you use that class which contains the main method as the name of the file. So when you save your program, you need to use, remember in Java, we said the name of the file should be the name of the class. Now, when you have 2 classes in one file, which name should you use? You should use the name of the class that contains the main function. That should be the file name. Because when you run your program, it is that file, that class that contains the main function that will be run. Okay? So therefore, the file name is testcircle.java. Since testcircle is public and it contains the main function. Each class in the source code is compiled into a .class file. So when you run the testcircle class, it will produce a file, an executable file, which is called a .class. What do we mean by that? When you run your program, remember Java is not a low-level language. Again, I won't go into the details. You assume that you passed through first year and you did introduction to programming and introduction to IT. And you were taught that in first year introduction to programming, you were taught that a program that is not written in zeros and ones is a high-level program. So it needs to be translated into a low-level program, zeros and ones. So Java is not a low-level language. We don't write zeros and ones only. So it's a high-level language. So it needs to be translated into machine language. So when you run your program, when you build and run your program, the Java virtual machine will translate your code from a high-level Java language into a low-level machine language. So that file that is produced, that is now executable because it contains machine code. That file is called the .class file. And if you check in the file where you've saved your program, you after running, you see a file that ends with .class. That is the executable file. Okay, when you compile test cycle on Java, two class files will be produced. One for the test cycle class. So you see a file that says test cycle .class, and then another one for the cycle .class class. So the cycle class will also produce a .class file. If you have three classes in one file, all the files will be run and they'll produce a .class file. But remember, the one that contains the main function is the one that should have the same file name. As you can see here, the test cycle class contains the main function. Because it contains the main function, the file for this Java class was named as testcycle.java. Okay, we make progress. So this is what happens when you run testcycle.java, which is in the same file. So these two classes are in the same file, testcycle and cycle. Both are in the same file. So when you run this file, it will, using the Java compiler, it will produce two files because there are two classes. So one file will be a .class file for test cycle, and this is the one you have here. The other file will be a .class file for the cycle class. Okay. So you can actually write these files in and save them in separate files. So you can have a cycle class and saved separately in the same directory, but as a separate file. And you also save test cycle as a separate file. Then you run them independently. And you can also combine them together. You know, if you combine the two classes in one file, actually instead of writing two class files, you can have one class file, and this class file combines everything. Here's an example. So if you look at this program, we have the cycle class line 1. Inside the cycle class, we have the main function line 3, the main function. And then we actually create objects within the main function. So we only have one file. So we can save this as cycle.java, and all the functions are written here, packaged together. And this is allowed, and you see this mostly done by programmers. So it continues all the way to line 41. These are the same code that you saw in the previous files. Okay, it ends there. And the program ends on line 51. Okay, combining classes. Since the combined class has a main method, it can be executed by the Java interpreter. So there's no need to have two .class files. So once you build and run it, the executable file, which is only one file, will be run by the Java interpreter and will show you the results on the console. This demonstrates that you can actually test the class by simply adding a main method to that class. So if you want to test a class, sometimes there's no need to create a separate class to test your class. You can actually embed the main method within that class. Okay. So let's just demonstrate a bit. Let me just go to IntelliJ and demonstrate. So for instance, here we have the class main. Okay. Let me rename it example. Save. I'll refactor because I've changed the name, so which means even the file name needs to change. So class example should be declared in a file name example.java. Make example not public. So I need to accept that so that it does that. Okay. Done what I didn't tell it to do. And may refactor. Let me leave it at that. So in this class, because there's a function main, you can see there's a function main in there. So because it's already there, it means I don't need to create a separate class. But there are times where you would have another class here, for instance, class circle. You know, it's outside that class. So this you can also do, but there's no need. What you can do is you can just make this a one class and then you embed the code in this particular class. That's what we are saying here. So let's make progress. Okay, so we've come to the end of this section. Let's have a look at some review questions, please. Or you should always pause the video and you should do these questions. I'll not do these questions with you in class. I leave them to you to sample them out and try and see if you can answer them. So here's question 1. Describe the relationship between an object and its defining class. What is the relationship? Okay. Question 2. How do you define a class? 1 mark. I think 4 questions. How do you declare an object's reference variable? How do you declare an object's reference variable? Okay. 4 is the last question. How do you create an object? Okay, so this is where we are. We are now done with topic 3. So next we shall discuss constructors. So this is what remains, the 14 altogether. So this is how far we've gone. We are now on topic 4. We shall upload further recordings in subsequent days. So for now, we end here and we shall continue with topic 5, which is accessing objects via variables references. Before then, we'll discuss constructors. So our next topic will be constructors. So see you next time, friends. Hope you enjoy the video tutorials. Goodbye.